Hello friends, today I am going to discuss linear algebra. Linear algebra is another fundamental branch of mathematics and it has some important applications throughout the scientific and technical. They are applied as a scientific and technical computing. So now here we try to understand vector space and linear mapping between the vector space, which can be represented as a matrix. So in a simply we can represent a vector and matrices symbolic using a simply matrices class, and whose elements can in a turn be represented by numbers, symbols, and even other attributes. So now first I am going to create a matrix with a numerical entries. So see here, so first let's see simpy dot matrix 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 and put here parenthesis and square bracket 1 comma 2. So we need to first install look like a simpy. So let's see here. So let's run import a simpy and simpy dot integer underscore printing, and from a simpy import I, pi and infinity. So these are the basic we can apply here. Yeah, it has been. So now first I am going to create here. Already I have created so many matrices, number of matrices here. So let's see. So first this is a matrix has been created, look like this way. And now the simpy dot matrix, if I write here same matrices, and but I am going to write as this, control C, and because square has not been printed, means symbol of matrix has not been printed, some software problem. So look here, just I am going to here this one position and another is this one. Now this one again I am going to print here. So double square brackets I have given here, it has been printed look like a row, and single bracket it has been printed like a column. So now another just I am taking as a simpy and dot matrix, simpy dot matrix, this one, and I am going to put here one brackets and again a one bracket, another brackets need to create one matrix and comma, next brackets it contains 3 comma 4 is the another matrix. So it has been created look like a 2 into 2 matrices, means 2 rows and 2 columns. So in this example we just demonstrate single list generated a column vector, and while the matrix required a nested list of a value. Another is the multi-dimensional arrays. In a NumPy, just we have already discussed, and the simpy.matrix object in a simpy is the only for up to two-dimensional array, like a vector and matrices. Another way of creating the new simpy matrix object is to pass an argument, the number of rows and columns, and functions that takes rows and column index as a arguments and return the value of corresponding elements. So try to use here. So let's see, look like a simpy dot matrix, and try to three rows and 4 column, and I am using here lambda. I am going to look like a lambda LAM BDA, and lambda means one is the M, another is look like N, and colon 10 will multiplied as a M plus N, multiplied M plus N. Let's see, I think lambda, it has been discussed here. Look. So I try to, yeah, it has been printed, look like a 3 rows and 4 column. So most of the powerful feature of the simpy matrix object which distinguish it from, for example, NumPy array are, of course, that is its elements themselves can be symbols expressions. So another way you can say here, if I am going to represent as a variable, look like a, yeah, some a comma b comma c comma d will equal to simpy dot symbol symbols. Now this one has been started, a comma c comma d, and now I am taking as a variable look like a M, yeah, A, capital M and A doesn't matter, and I am going to write here simpy dot matrix, simpy dot matrix, and double, and write here A comma B, and another bracket start, another C comma D. So these are the variable. Now I am going to print here capital M. So look here, is it working and not working? I think, yeah, it has been printed 2 cross 2 matrices, and it can be represented with a symbol variable for the each of its elements. Now I am going to the multiply, so denote a matrix multiplication. So if I write here M and cross M, so look here, I have gotten the output as a variable look like this one. Now if I want to look like another x as a variable, so I write here x will equal to, you can write here that x will equal to something like simply dot matrix, and I am going to write simply dot symbol, simply dot symbols, parenthesis x underscore 1. You can write here x underscore 1 comma x underscore 2. And I can now I want to multiply m into x. Let's see, first you can print here the x. So x underscore x and another is the x underscore y, and now I am going to look like this, and now I am going to multiply here capital M to x. So in addition to arithmetic operations, so many standard and the linear algebra operations on a vector and matrix are also implemented as a simply functions and method of a simply dot matrix class. So sometimes we see the problem that can be solved with the symbolic linear algebra using a simply, but which is not directly solved purely numerical approach. So some parameterized linear equations systems like Cramer's rules, Gauss and others. So we see the some numerical methods means like to choose a particular value of the parameters p and q before, and we could begin to solve this problem. For example, so using LU factorizations by computing the inverse and the matrix on the left hand side of the equations, and with the symbolic computing approach. The other hand, we can directly proceed with the computing the solutions if we carry out the calculations analytically by hand also. So let's see, just try here to p and comma q as a variable will equal to simply dot symbols and p and q p comma q, another variable look like m will equal to simply dot matrix, simply dot matrix and 1 comma p, another q comma 1. Now m will equal to m has been printed look like this, and now b equal to, you can write here look like this one has been printed. M has a simply matrix, So look here, yes, I am using a basic something. Look here, and another the B will equal to, so B will equal to simply dot matrix dot matrix double brackets and simply B will equal to simply matrix and simply dot symbol. So first you write here the simply dot symbol, simply dot symbols parenthesis where B underscore 1 comma B underscore 2, and now you can print here B. So this one is a B has been printed. So and then LU solve the method to solve the linear equation system. So let's try, because B has been printed, look like this. Simply matrix 1 comma P, okay, right here. So I can PY matrix simply dot SYMBOLS, okay. So I think it is possible to it has been printed. Like this side. I hope my internet connections may be slow, otherwise it is a working very well. Sometimes if your internet connection is not a good, so it is not a working properly. So let's see. Yeah, it is clear. And now I am going to write here x will equal to, so let's see, x will equal to m dot lu m dot l m dot capital L here lu, I think, yeah, I have to check here, yeah, lu capital, okay. So lu solve, I think lu solve, yeah, this is, so lu solve, and now write here B. So B you can put here, and now is it possible to solve this equation? So LU, B and M, it has been go, okay, sorry, I need to print here the X. So right, it has been done. So this is a way. So one more alternative, we can also directly compute the inverse of the matrix M and multiply with this one. So yes, I have one more alternative way. Try to write here x will equal to M dot inverse dot INV inverse parenthesis, this will multiplied with the B. Oops, not inside of this. So this will multiplied with a B. and now get the output here x. So similarly, I think it is not working because MINV parenthesis need to put here small b, not a capital V, because we have already assumed here agency is okay. Something is happen automatically, so don't worry. So set what is this? So we don't need here basically. Now we try here. Yeah, right. So this has been printed. So similarly, we can also use the sum selected functions and method for operating on simple matrices like a transpose, adjoint matrix, trace, the compute the trace, sum of diagonal elements, det, compute the determinant of the matrix, inv, just we have already discussed. LU decompositions means compute the LU decomposition of the matrix. LU solve means solve the linear system of equation like a mx will equal to b for the unknown vector x and using the LU factorization. QR decompositions means compute the QR decomposition of matrices. QR solve also diagonalized norm of a normalized of a matrix, and null space compute the sets of a vector, and rank singular underscore values and so on. So these are the way we can easily try to understand. So linear equations can apply. Now next, first I will try to discuss some plotting and visualizations, because just if I learn the plotting and visualization, then it is better to understand linear equations, because so number of equations has been written, but we need to understand whenever get to a plot, and we can get a output results. So something is like a visualize. So try, because next first we understand to plotting and visualize, then we will try to equation solving. So scpy, how to importing means we try to the import the simply scpy and others also. Then we will solve the n into n matrices like a linear equation systems and others. So I hope this is a better way to understand, I don't think so, and next time we try to describe more. Thank you.